Kia ora Year 12, especially Hugo, Han and Arnav, making this video for you guys who are at home isolating, and this is just going over the starter that we did today. So what we're looking at here is how we differentiate logs and exponentials. Remember, these are my basic rules. If I've got the natural log of x, then the derivative is simply 1 over x. In these questions here, you're going to need to do two things. Sometimes we can simplify what we're starting with first. I'm going to be nice and give you a clue about where I can do that. And often we'll need to use the chain rule. The other thing that we've got in these last couple of questions is differentiating e to the power of x. So the derivative of e to the power of x is just e to the power of x. I just need to apologize for the very loud dog chewing noises in the background. Sorry guys, but I'm sitting in the living room at home and I can't be bothered moving to my study, so you'll just have to put up with it. Right, let's look at this first question here. Two ways to do this one. Now the first way is just to get on with it and use the chain rule. I've got f of x is the natural log of 4x. This is the inside function, and ln, the natural log, is the outside function. So f dash of x is going to be 1 over all of this, so 1 over 4x times the derivative of the inside function, which is just 4. That gives me 1 over x. And you might notice that somehow this has given me the same gradient as my basic function of the natural log of x. And if you think about the log rules and the graph, we can have a look at why that is. So we can rewrite f of x as the natural log of 4 plus the natural log of x. And if we graph that, what we've got is just a vertical shift upwards. Sorry, I have to have that line be completely flat. There we go. Yeah. When I work on this part of the screen, sometimes OneNote shuts down, so hopefully that won't happen. So the natural log of x graph looks like this, right? This is the point 1, 0. And the natural log of 4x is just this curve shifted up by a bit. So it's shifted up by 1 point something. You can go check that. And so those two lines are parallel. And that means that the gradients are going to be equal for any x value. Okay, so if I do that simplification first, differentiating this is really easy. This is a constant, so the derivative is 0, and this is just 1 over x. Okay, question 2 is one where I can't really do any simplifying. I just have to do the chain rule straight away. And question 3 is one where simplifying is going to make life much, much, much better. Okay, so question 2 first, and then it's close relative to question 3. So g of x is equal to the natural log of x squared plus 1. G dash of x will equal 1 over x squared plus 1 times the derivative of the inside function, which is just 2x. So that gives me 2x over x squared plus 1. Now, h of x is nearly the same, but somehow much worse. If we start doing it like this, without simplifying, we've got the natural log of root x squared plus 1. So the first step is to go 1 over root x squared plus 1, right? This is the bad way to do it. And then I've got to differentiate this thing here. So we might want to write that as x squared plus 1 to the power of a half. So let's differentiate this just for some practice. So it's 1 over the thing because it's the natural log. Right? So this is the outside function. This is the inside function. Now the derivative of the inside function is going to be 1/2 times x squared plus 1 to the negative 1/2 times the derivative of this, which is 2x. And that whole thing is going to give me x over root x squared plus 1 times root x squared plus 1, which simplifies to give me x over x squared plus 1. But that was quite a bit of work, not masses of work, but quite a bit of work, because we had all of this mucky stuff here. So let's see a better way to do this question. We've got h of x is equal to the natural log of x squared plus 1 to the power of a half. We can use our log power rule and write that simply as half of the natural log of x squared plus 1. This is suddenly very easy to differentiate. It's just going to be 1/2 times 1 over x squared plus 1 times the derivative of x squared plus 1, which is 2x. So look at that, way less work. But very cool that we can see that we got the same answer the long way. Okay. All right, 3 questions to go. The next one is one where we really should simplify. We don't want to be working with a quotient rule inside a log unless we really have to. So f of x is equal to the natural log of x plus 1 over x, which is the natural log of x plus 1 minus the natural log of x. That means that f dash of x is equal to 1 over x plus 1, and there's the derivative of this is just 1, minus 1 over x. So there you go, that's that one done. Now we've got 2 left to go. This one is going to be a product rule one, and this we can either do as a product rule or a quotient rule question. I guess what I should have said at the start is I'm hoping that you are actually doing these questions as you're watching, okay, because it's much more useful. So this is u and this is v. So by the product rule, g dash of x is going to be equal to u times v dash plus v times u dash. And if you want to write those derivatives out slowly, that's totally fine. For this one though, I probably wouldn't bother because the functions are pretty simple. So g dash of x is equal to the first thing, so x times the derivative of this, so times 5e to the 5x plus 2, plus the other way around. The derivative of this, 1 times this function. I feel like in class we got something different for this. No, I think that's right. So it's e to the 5x plus 2 into 5x plus 1. So that's correct. This is enough, but it just looks really ugly to me, especially the 1 times here. Let's just get rid of that. Okay, on to question 6, which is x over e to the x. So I would probably do this as a product rule question because it's a pretty simple product, right? I've got x times e to the x. So h dash of x, following the same pattern as above, is the first function, x, times the derivative of this one. So x times negative e to the negative x, plus the other way around. The derivative of this one, 1, times this function. And cleaning that up gives me e to the negative x into 1 minus x. Okay, so that's that one finished off. Let's get rid of all of this. So I'm going to show you how to do it with the quotient rule because it's not that bad with the quotient rule either. So doing this with the quotient rule, the first thing that I do, well, the quotient rule says v squared times vu dash minus uv dash. So squaring the bottom line, so what have I got? X over e to the x is h of x. Squaring the bottom line gives me e to the 2x, and it's ex times the derivative of this, which is just 1, minus the derivative of the bottom line, which is e to the x times x, the top line. That gives me 1 minus x times ex over e to the 2x, which is 1 minus x times e to the negative x, which is what we got before. Okay, so I've put in the tracker sheet what you need to do in 4a and 4b, which sadly for you guys is actually most of exercises 4a and 4b. The good news though is that you'll find that I've taken some of these questions from those exercises and I've just amended them very slightly, or actually in some cases I think I've just lifted them directly. Okay, so really good to do heaps of practice at these skills. They come up very often in NCA level 3, and they give us a good base for going on to the harder differentiation A-level work. Please shoot me an email if you've got any questions, especially if you actually are Han, Arnav or Hugo, and hello to anyone out there else who's watching.